So, hello everyone. My name is Elodine Coquelet, and I'm currently a student at EPITA. I am working at CEA for my internship, for my end of studies internship. My work takes place into the European project CATI for personalized medicine. I work on the development of a data lakehouse to train some artificial intelligence models to predict the response to anti-tumor treatments. I will start this presentation by briefly presenting to you the CATI project. So the CATI project is one of the 4 projects funded in 2021 by the European Commission for as a part of the AI for genomics and personalized medicine action. The objective of the CATI project is to develop a digital infrastructure based on AI, relying on large genomics and clinical data sets that can support clinicians in their choice for their cancer patients. It is prototype on the issue of the choice of targeted and immunotherapy to treat metastatic kidney cancer. So every data we use for now are linked to kidney cancer. To carry out this project, the CATI consortium is multidisciplinary. So we work with clinicians, bioinformaticians, ontologists, and a lot of other disciplines. To prototype the data lakehouse, we rely on existing public data, either free or under access control, and new data generated by the partner of the consortium. The workflow setup for the project started from the definition of the clinical problem and goes to the development of AI models that are integrated into a prototype digital platform intended for clinicians and patients. I will focus in this presentation only on the data management stage. For the data management, there is multiple technologies that have been developed. I will now present 2 of them that the data lakehouse is issue of, and then I will present to you what's a data lakehouse a little more. So a data warehouse is a structured storage model for highly structured data that has been processed to be stored in one specific form and retrieved in the same form. It means that if your data are not structured, you cannot do a data warehouse. A data lakehouse storage model is also for structured data, but also for semi-structured and unstructured data that can be processed after retrieving the data from the data lake to be used directly for data analysis or to feed some machine learning models. And finally, the data lakehouse is a data lake extension used to manage data concerning one specific objective and supervised by a metadata, security, and governance layer. The data lakehouse we designed for the CATI project is organized into 3 zones. The raw zone, which consists of different types of preprocessed data from sequencing experiments, patient biological and clinical feature, reference database such as gene name ontologies, and the password annotation. The silver zone, which consists of data generated from advanced bioinformatics process and organized into different tables and view to optimize query, extraction, and the governance. And last, the gold zone, which consists of the interaction zone between the data lakehouse and 3 types of access. The first access is the analysis of the data analytic by query. The second is the extraction of data to train machine learning model. And the last one is also the extraction of data, but this time to feed a knowledge graph that will be partially used to think of for the explainability of the response given by the artificial intelligence models. Our structure is divided into 11 tables, 5 describing data related to the patient clinical feature, its tumor biology, and its treatment. We have the drug, the prognostic, and the outcome of the treatment. We have 2 tables describing the genomics profile of the patient's tumor, one concerning single nucleotide mutation and their predicted biological impact, the other for the structural variant. We have 3 tables. The first one for the expression values per genes, which provide per patient, and the other 2 derive from the first one, which provide per patient the deregulation of the biological pathway and the cellular composition of the tumor microenvironment. We have a metadata table that has been created to keep track of the origin of the data for the governance layer that will allow us to manage access to data depending on the right access. Since the project is done by a consortium, each partner doesn't have the same access right. So we need this table to be able to manage their access to the data. Since this data lakehouse is destined not only for informatician, but only for clinician and patients, we have created some joint tables, which are the fusion of multiple tables to simplify the use by people not used to the data lakehouse structure or to the manipulation of data. We prototype the data lakehouse using 2 data sets, which you can read the name of the article if you are interested. We have in total 1,487 samples treated with 4 different drugs or drugs combination and 2,287 experiments. In the future, more data sets will be added to the data lakehouse. To test the structure of our data lakehouse, we have established some user cases. The first one, let us investigate whether the 10 genes frequently mutated in kidney cancer are associated with patient response to treatment. By implementing the 4th step you can see here with the SQL queries and a statistical test, here we use a Fisher test. We have been able to find that the mutation status of MUX16 and ZNF850 are associated with a good patient response. So of course, this query will have to be tested again when we will have more data to see if the significance is still here. The second query asks for the same frequently used gene mutation if their mutation status is associated with a change in gene expression. It uses the connection between the expression and the mutation table through the table metadata. We did not obtain any significant association with the data currently in the data lakehouse, but we will be able to test it again. For this test, we use a Wilcox test. In conclusion, we prototype a data lakehouse integrating patient molecular and clinical data with the aim to support the development of artificial intelligence models and their explicability. So far, we were able to validate the relevance of the table structure with 2 data queries. There are work in progress on the semantic harmonization of data using ontologies, because the different data sets we use in our data lakehouse don't use the same ontologies. We also work on the deployment of the data lakehouse on an academic cloud infrastructure hosted by CA and Cineca. And we also work on the establishment of the data security and governance strategy for the integration of restricted access datasets. I'm available for the poster talk after this presentation. I'm at the poster 2, so just near the other presenter. If you have any question, you can contact me at my email elodine.coquelet@gmail.com. It's my personal one, so try not to send me too much email because my professional one will be disabled at the end of my internship. But if you have a question more on the CATIB project in general, you can contact Christophe Bataille, which is my who is my supervisor at christophe.bataille@cea.fr. Thank you for your attention.
Thank you. So thank you for your nice presentation and description of very interesting project which you're taking part in. One question.
Okay, thank you very much for your presentation. The types of data different you are collecting is very impressive. I have a question. You already mentioned something about restricted data access. Yeah, and in a situation of patient data, there is always the question about privacy, and so how actually who is going to have the access to this repository, on which level of data, and how this is going to be solved?
Most of the time, we have some partenariat. So, for instance, with CA, we have a partenariat with the Grenoble Hospital, and if we have some data that are restricted, only the people at CA will be able to see that data. So for that, we will use we have two options we are thinking about. The first one is to use Atlas, Apache, and Ranger to restrict to see software that allow us to restrict access. The other one is simply to completely block the access to the data lakehouse itself. And when a user connects, we create a view of the data lakehouse only with the data he can see with his access right.
Okay, thank you.